10.1, the three-dimensional coordinate system. What you should learn. Plot points in three-dimensional coordinate system. Find the distance between points in space and find the midpoints in space. And write equation of spheres in standard form. We're going to talk about all about the 3D coordinate system. And basically, you get a 2D coordinate system. Right here's my XY coordinate system. And you also have Z value. So it's like the corner of a room. So here's the floor. Here's a back wall. Here's a side. The floor is an XY plane. The sidewall here is a YZ plane, and we have an XZ plane. And by the way, this is only the positive version. These actually extend out to the negative version as well. Like this is negative X goes over here, negative Z goes down, and then Y goes back. There's actually a whole 3D spot you can do it in. And this is what it looks like in geometrically, 3 planes crossing each other. Okay, let's figure out how to plot a point. Well, first, we always start off with a little base graph here. Then you make this one diagonal. The diagonal one, here's your X, here's your Y, here's your Z. We'll plot a point that's 3, 4, and 6. Then we'll plot 2, negative 3, and 3. Here's my grid. We'll just do one on the positive to start off with. 3, 4, 5, 6. Okay, we want to go, this is X, Y, Z. On the X, we're going to go, this is the idea. On your X, you're going to go 3 on your X. 1, 2, 3, right here. And then from this spot, you want to go 4 on your Y. You want to go like this direction. 1, 2, 3, 4. Notice how it doesn't line up perfectly because you're starting further back. It's like 1, 2, 3, 4. And then from that spot, you're going to go up 6 to the Z because Z's up and down. So you can go like 1, 2, 3, then 1, 2, 3, 4 over here, and then you go up 6. 1, 2, 3, 4, 5, 6. They should not line up perfectly because you're in a 3D space and we're starting further back. We're starting below the actual line. If you're having a hard time with that, what we do is this. Your X is going to be 3. On the 3 over X, we're going to draw a line parallel to the Y through that line of 3. Like that. And then our Y is 4. On the 4 over Y right there, we're going to draw a line that's parallel to the X. So try to make it parallel to the X. That'll be perfect. It's like that. So this is where we're at when we're at 3, 4. 3, 4 is just 3 on the X, 4 on my Y. We're right there. Now we got to go up 6. We're going to try to do the same concept. We're going to try to draw a line parallel to Z, straight up. And then I got to come across. We're going to use this line here. It's this diagonal from there to there. And I want to draw a line parallel to that through 6. My Z is 6. 1, 2, 3, 4, 5, 6. We're going to try to match this line up here. Like right there, that point right there is the point 3, 4, 6 in 3D space. So again, a lot of times I like to think about this. I just go, okay, I'm starting at 0, 0. Then I'm going to go 3 on my X. Then from there, we're going to go 4 on my Y. And then from that spot, we're going to go up 6 for my Z. So that's the way graphing works. So you could either go 3 in your X, then from that spot, go 4 over your Y. And then from that spot, go up 6. Or you could try to make lines that are parallel. Go lines parallel to your X, to your Y. A line parallel through that point they match, through your Z, and then connect it all. Okay, but how about the next one that has a negative value? The negative values, you actually extend them. So that's like, this is Z, this would be negative Z down there. This is X, negative X will go over here. And then this is Y, and negative Y will go over here. Like that. So we're gonna go to my X, right there. That's where I'm at currently. And then I gotta go negative 3 on my Y. Y usually goes this way. From this spot, we wanna go back 3. 1, 2, 3. It's like right there-ish. 2 my X, 3 my Y. Then I gotta go up 3 in my Z. 1, 2, 3. Right there. About. That's where that point is. And this one we went 2 in my X, and then we went back 3 in my Y, and we went up 3 in my Z. So you get a point about right there. So that's how you plot in 3D space. Distance to midpoint formulas. They're actually very similar to the way they are in 2D space. Only difference is now for the distance formula, we add a third component, which is the Z's. That's it. Exact same formula in 2D space, square root of a squared plus b squared. In 3D space becomes square root of a squared plus b squared plus c squared, the third dimension. So if I was doing this problem here, I want to know the distance. x1, x2, y1, y2, z2. The distance formula is just going to be square root of x2 minus x1 squared plus y2 minus y1 squared plus z2 minus z1 squared. Notice and type those all in. So I'm going to get negative 2 minus 3 squared plus 4 minus 1 squared plus 1 minus 0 squared. This is going to be negative 5 squared, which is 25, 3 squared, which is 9, and then 1 squared, which is 1. So I get 10 plus that, square root of 35. That's the distance between these 2 points, square root of 35. Midpoint formula, the exact same concept. You're just adding a third component, which is the z coordinate. So it's the exact same concept. This midpoint of 2 spots is this right here. Third spot, you add a third component. If I want the midpoint of this, you're basically taking the average of each one. For my x, it's going to be 5 plus 0 divided by 2. For the y, it's going to be negative 2 plus 4 divided by 2. And for the z, it's going to be 3 plus 4 divided by 2. We get 5 over 2, 2 over 2, and 7 over 2. Or a little bit reduce 5 over 2, 1 and 7/2. That's the midpoint of those two spots. 3D space is super easy once you have the basic formulas. How about an equation with spheres? Spheres 3D. Well, it's pretty much the equation of a circle, just we add the third component. So it's h, k, and j now. Just like a circle, we just have that new component added. So let's do this. Find the standard equation of a sphere with the center of that and a radius side. Does this sphere intersect the xy plane? Our formula is going to be x minus h squared plus y minus k squared plus z minus j squared equals r squared. Let's plug in our points. H, k, j. I get x minus 2 squared plus y minus 4 squared plus z minus 3 squared equals 3 squared, which is 9. So that is our formula. Now, does it intersect the xy plane? Well, we could figure out logically, but we can also do this. If we kind of wanted to graph it just real quick, right, it would be at 2, 4, and 3. 2 this way, and then 4, and then 3 up. Now, my radius is 3. We're just going to go 3 down, 3 right, 3 up, 3 left. And get a sphere. Now, it is 3-dimensional. It's going to look like this, 3-dimensional. This is the xy plane. XY right there. That's xy plane. We went 2 this way and 4 this way. We went 3 up. Our radius is 3. It will touch the xy plane. Does the sphere intersect the xy plane? It's 3, so we're just going to touch it. Example 5. Find the center and radius of the sphere given by this. This is conic section review. We're going to do the same thing we did with conic sections. We're going to rearrange all the x, the y's, the z's, and set it equal to some constant. And then we're going to complete the square. So let's do that. Rearrange it. X squared minus 2x. And then next we're going to do the y's. Y squared plus 4y. And then we'll do the z's plus z squared minus 6z. And then we want to move the 8 over. We want the constants on the other side. We have that. And now we just have to complete the square 3 times. So this one, negative 2 divided by 2 squared equals negative 1 squared, which is 1 plus 1 plus 1. Next one, 4 divided by 2 squared is 2 squared, which is 4 plus 4 plus 4. And the last one here, negative 6 divided by 2 squared is negative 3 squared. 9 plus 9 plus 9. And then we simplify the left hand side. So this is going to be x minus 1 squared, always the thing before you square it, plus this side, y plus 2 squared, plus this side, z minus 3 squared. And then we add up all these together. I get 10, 14 minus 8 is 6. 6. That is center in the, I have to find the center of the radius. So the center of our sphere is going to be 1, negative 2, 3. It's that opposite. And our radius is going to be the square root of that. Square root of 6. So that's our formula for our sphere. That's our center, and that's our radius. And that's the lesson.